Bismillah. Alhamdulillah. Okay, boys, welcome to the past paper discussion session. So this is 2023 paper, Aerial ICT. Since we have already done few sections, I mean around 13 questions we did in our last past paper discussion session, and it was a live and did not record it. So I'm gonna start recording this particular paper from first question itself. Okay, so without a big introduction, you guys already know what we were doing. So we'll get back. Uh, and I'll be discussing from the start again. Okay, those who are in the classroom, they can skip the first, first session or first, 13 question. If it is need, just you can go through this. Okay. Which of the following statements are correct? This is the first question. The word processor and spreadsheet software belong to the category of utility software. Okay. Utility software comes under the system software. So if you take system software, this is utility software, then we have operating system and we have language translators. Okay, utility software, there are a lot of different utility software. Some of the popular ones are defragmentation software. Then we have antivirus software. And we have compression softwares, like, make things compressed, zipping it up. So these are kind of utility softwares. But word processor and spreadsheet software does not belong to these categories. Okay, so these two softwares, like specifically word processor and spreadsheet softwares, belong to these are baby questions, by the way. Like in the first question to open, it's a very simple question. So these two are application softwares. Okay, good. So first one is indeed not correct. So the second one is a compiler is an example for program translator. Yes, there are three types of program translator we have to concern. One is assemblers, used for low-level languages. Then we have compiler and interpreter for high-level languages. Yes. It is illegal to use a proprietary software without obtaining its license. So proprietary software, the softwares that we paid and get, we don't own the code. We just have a license. Usually it is you will be saying I agree to ULA agreement, which is end user license agreement. And yes, it is illegal to use it. So it's called as software piracy. Okay. So the answer is B and C only. So that's the first question's answer. Second question. Personal information of students and their exam marks are input to a student's information system, which is called SIS. Marks obtained range from 0 to 100. So there is a range. You cannot enter less than 0 or greater than 100. A student has to study a collection of compulsory and optional subjects. So he can choose set of compulsory subject, and there are subjects which is optional, and sit for the relevant examinations. Which of the following are suitable data validation for the above system? So if you take this above system, it has two main data they're going to talk about. One is the marks and other one is the subject. So we'll see what's the first one. A person sub for the marks of all the subject taken and not taken by the uh, student. The thing is, they should be more tricky here. They have been more simple in this case. Okay. So if they cut this out, the question will be become good. I mean, they have said taken or not taken and presence check. Presence check is only used when the things are compulsory. You have to enter. So it's my kind of things. They should have avoided this, so make the question a little bit tricky. And this is not the case, because if the presence check is there, they have to enter marks. Even entering 0 marks for the subject that you have not taken is not a good practice, because you haven't got 0 marks. Simply you are not selected that exams. Anyhow, the range check is whether the input marks is between the range from 0 to 100. Yes. The data type check to ensure that the input made for the telephone number. So they are giving a telephone number here as well. So the student contains only digit. That's also correct. Okay. But when it comes to database systems, we have a problem with having digit only, because when you say 077, it will save as just 77. So that's nothing to do with this, like, so this is just an explanation. So you have to use a string to include that front or tail, sorry, heading 0. So here, yeah, in this case, yes, you have to have a data type check to include only digits. Okay, so answer is B and C. Once again, the fifth answer. Okay, third question. The existing book management system in a school library is used with a computer, a monitor, and a keyboard and mouse. So you have a computer, monitor, keyboard, and mouse. The school management must minimize the time taken presently for the book lending and returning process. Which of the following is most suitable for this purpose? So they have a keyboard, mouse as the input devices, and a monitor and a computer. Like, monitor is the output device, and they say they should be saying like not a computer. It should like, uh, the tower thing there. Okay. So using a digitizer. Okay, digitizer is what you see in your smartphone. The top layer that you touch, the glass layer usually that you touch is called as a digitizer. It finds you the X and Y coordinates. When you type like have a touch, it will find the X and Y coordinates, and behind that is the screen. Screen is an output device. Digitizer is an input device that like uh detects where you are touching. So nothing to do with that. External hard disk, nothing to speed up. Okay. Using a touch screen. So same thing with including a screen. So usually touch screen is a digital plus a screen. So nothing to do in this case as well. Using a magnetic stripe reader, usually we have a magnetic strip in like debit and credit cards. If you have then just check it out. So behind you'll have a black color, like almost like black, it is dark brown color strip that has magnetic elements that have data stored. So we don't usually give this to students because it is expensive. The card itself is expensive. Usually nowadays they take around 600 rupees to give you the card. That include the price of the card and with the NFC tags and all these expenses. Might be a little bit margin from the company, the bank. Anyhow, it is expensive. So a kind of expensive, and the reader is also you have to pay for that. And yeah, technically it's not that recommended for keeping in libraries. So what instead you can use is using the barcode technology. Okay, so if you use barcode technology, most of the libraries are using that. You can stick a barcode to the uh, book and give a card to the user having a separate barcode. It will cost around like maybe 100 bucks. Okay, so this is for the user and this is for the book. There will be a sticker printed on the book. It will cost about like five bucks, and you might have to buy a QR code, sorry, a barcode generator. Sometimes it is free. So the cheapest and best option is in this case is a barcode reader, which is again the answer number 5. The question number 4. Listed below are some phrases about the internal operation of 3 printers. So printers, like there are 3 main printers that discussed. One is called as dot matrix. Okay, they have a needle matrix of needle. So I think you might have known the matrix thing from your O levels. So if you have something like this, it is like a matrix. Okay, so there are a lot of needles there. It punch again a ribbon to make the uh words that you type. So if you zoomed in one of the prints from dot matrix printer, you can actually see dots. So for example, A will be like this. I don't know, it looks like an A or not. So this is like, this A I was talking about. Then you have inkjet printer. So these jets are called as the nozzles. There are small nozzles and they spray the ink to the paper. Okay. So you might have seen a moving part inside a printer. That is the cartridges with the nozzle. So if you have the paper, it will spray the droplets where it needed. Then that is inkjet. Last you have laser jet or laser printer. Okay, this uses a laser technology. So put it very simply. Okay, there's a drum. I mean, there's a cylinder. They burn, like, they put laser lights of what you have to print. For example, uh, myself. So this is like, carved by laser beam, and then it is rolled into a dry set of ink. Ink is what we called as like liquid, like, ink powder. Actually, it's dry ink. Okay, it's dry, it's powder. Then when this cylinder rolls on the powder, it uses magnetism. So this actually charged in positive and negatives. Okay, when the laser beam goes, like, it changes the north pole and the south pole, and the dry powder attracts to that, and then it will placed on the paper. So only what you have written have taken this small powder, then it will placed on the uh, paper on top. So it will be like this. Paper will be there, the dry ink will be there. Then it goes for a heating process. So it will be infused. Okay. So this is why the out of the laser printers you will feel the heat is there. Even if you open a laser printer, it says caution, it's hot, because heat is used for the fusion. Okay. We'll go to the discussion here. A moving print head striking ink ribbon against a paper. So ribbon is used, head is used. Actually, this is a needle head. So this is dot matrix. Dot matrix. Some people say like that. Okay. Don't attract to what is printed on a cylinder, which is transferred to the paper. Of course, that is laser. Then nozzle spraying into the paper is inkjet. So answer goes as dot matrix, laser, and ink. Dot matrix, laser, and inkjet. The answer is the first one for the fourth question. Next one, fifth question. Which of the following will cause the CPU to execute in a different set of instruction? So CPU is working on one set of instruction. So for example, say add pi comma 3, and this is a calculator app. It works on the next instruction. The PC holds the program counter, holds the next instruction, so on and so forth. The CPU is working on it. So he's doing one thing, and they ask different set of instruction. Okay, different set of instructions. Okay. First one, a context switch. A context switch stops the current process and executes another process. Okay, so P1 is stopped now. After sometimes after the context switch, like, saving the PCB of P1 and loading the PCB of P2, everything is taken by the OS. OS controls all the process, like, of context switch. Then it goes to P2. Yes, it's a different one. An interrupt. Yes. Okay, you are working on, like, you're just watching a video, and you're like, you have put a printout. Your printing is going out of paper. Okay, then it's take the signals and tells the CPU to display the user this message, like, put paper or put ink. Okay, so that is an interrupt. Okay, disturbance. Yes, it has to stop what he does, and it has to go for interrupt service routine, which means it just go and check the interrupt. It stops the current work. Yes. User select the shutdown option on a computer. So when you click shutdown, it's a command that computer should execute no matter what you are doing. Okay, it's one of the user's command. It has high priority. When you ask him to shut down, it has to shut down. So whatever the work it does, it has to stop and process the shutdown. Okay, which is another set of instructions. Okay, so yes, it's going to be all A, B, C. That's the answer for fifth question. The sixth question goes, the program run fastest when the data is required is in the blank. So the CPU is here. Again, we are talking about the CPU. We are very close to CPU. And the instructions are like coming in. Okay. So early in the days, we had the RAM, only the RAM, which is made out of DRAM and CPU. They were working well. Okay. Then what happened was CPU, like, performance went high. He was now working, willing to work a lot, but the supply was not enough speed of the CPU can work with. So the computer engineers work around, because if you want to have a RAM and if you want to speed the RAM, it is not going to be on the possible state. So they introduce the cache memory or cache memory. It's how it's spelled actually. It's cache. Okay, CACHE. Okay, so it's cache memory. They introduce the cache memory in between, and it is made out of SRAM. It's another technology, and they could not replace RAM with the total RAM with SRAM because it's expensive. The cost per bit is high. So this is like a buffer area, like the supporting area in between. So CPU takes the data from here. If it is there, it's a hit. If it is not there, it has to take an again from the RAM to cache, and then only it come. So if the item is on cache, you can find out if the answer is cache. So cache is not a direct answer there. They have going zooming the caches. So we have L1 cache, L2 cache, and L3 cache. So L3 cache is the largest and the slowest among, but even that is double speed of the RAM. So cache is very fast. So L1 has the highest speed with the lowest capacity if you compare about the caches. So answer is not on the hard disk. Nothing. The CPU cannot access anything in the hard disk because this is secondary storage. So only the primary storage that CPU can have the direct access. So hard disk not going to be the thing. L1 cache is going to be the answer here. And L2 cache is after the L1 cache. Magnetic tape, no. Has nothing to do with this one. I think they didn't have choices and they have put something there. And main memory, no. In this term, that is L1 cache. They could have put L3 cache instead of magnetic tape. Okay, good. So what is the binary equivalent of decimal 13.125? So you just have a very quick conversion here. So 13 is and 0.125. You have to separate it out. Then you have to convert this in the normal format. Okay. Then there is another method of converting this. So I'll be just choosing the most and very suitable one which is going on. So if you have practiced well, you'll end up on this. So this is 8, 2. Okay, I missed it. It's 8, 4. So it's 12 and 2, 1. So this is going to be 13. So at this point, you should have a lot of practice in this one. So 125, how do I make 125? So if I put 1 in the first one, that's going to be half. That's going to be 0.5. I cannot use it. Then 1 2 to the power 2, which is 1 over 4, this is 0.25. And it is also not going to be the case. Then I go to 2 to the power 3, 1 over 2 to the power 3. That's going to be 0.125. That's what we are exactly looking for. The answer is 1101. Point first one, no, I don't want a half. I don't want a quarter. I just need a 1/8, 1 over 8. Okay. So answer is going to be the third one. Lovely. Yes. So which of the following are equivalent to octal 674? Okay, so they are giving one in binary and one in decimal and one in hexadecimal. The easiest to convert is to binary and hexadecimal. I'll show you very quick method to do that. You should be knowing by this point. Okay. So octal, when you convert to binary, you should use 3-bit conversion. Okay, so because maximum number is 7, you just need 3-bit to represent 7. So here 111, this is 0, sorry. This is 100, that is 4, 6 is 110. So this is binary. And if you want to convert to hexadecimal, that is a 4-bit conversion. Very easy. You just go to 4-bit and put a line over here another 4-bit, put a line over here, then convert it. So 1100 is it's going to be 12. 12 in hexadecimal is ABC. It's going to be C here. This is 1011, that is 8. Like 10 and 11. 11 is B, and this is going to be 0001. This is called 1BC. Shall we check on those things? It's 2BC, it says. I made a mistake there. Okay, so according to me, this is incorrect. I will check the first one. 100111110. Okay, this is correct. Now we just have to convert to octa, to decimal. So 674 again. So we can just go for 8 to the power 0, 8 to the power 1, 8 to the power 2. This is the normal way that you convert to like anything to decimal is this way. So 8 to the power 0 is 1, 1 into 4 is 4, 8 to the power 1 is 8, 8 into 7. So 64, 8 into 8 is 64, minus 8 is, yeah, 56. Plus 8 to the power 2 is 64 times 6. Okay, 64 times 5 is 320, plus 64, sorry, yeah, plus 64. So you have 384. 384 plus 56 plus 4. This is 10, 14, one remainder. 8 plus 6 is 14, 444. Just a quick math there. So this is correct. This is correct. The answer is A and B only. Yeah, data conversion. Uh, Address of an instruction shown is in 5A1. So whenever see 5A1, you should know that is hexadecimal. So they should not mention this one at your stage. Okay. So whenever you see this one, you should know that is going to be hexadecimal. Okay. So that should be a guess. They have to remove this one at your stage. What is the address of a in decimal? You just have to convert to decimal. So here 16 to the power 0, 16 to the power 1, 16 to the power 2. So see how they have given. They have given 5 here. A is representing 10, sorry. So which means it's easy multiplication. If you are good in multiplication, you're going to get the answers like that. Okay, 16 to the power 0 is 1, anything to the power 0 is 1. 1 into 1 is 1. 16 to the power 1 is 16. 16 into 10 is 160. 16 to the power 2 is that 512? Yes. 16 into 16 is that 512? It's 256 now. Yeah, it's 256. 256 like into 5 is 2560 divided by 2. That's going to be 2560 divided by 2. It's going to be 100, sorry, 200, 250, 100, 280, I guess. Okay. So 160 plus 1, it's going to be 1. 8 plus 16 is 14. 4, 1. 1441. So answer is going to be 491. The answer is second one. So guys, this is what I say always. Okay. So if you are good in something, take it to the perfection level. Okay. So increase your time here. Just spend a little time here in this stuff that you already know. So you can get some time in the little bit harder stuff. Going ahead. Okay. Question number 10. It's a document contains 2048 characters, including spaces and line breaks. So space is also a character. Line break is also a character. You should know that. Line breaks are also characters. How many bits are needed to encode this document? ASCII also using the parity bits. So ASCII uses 7 bits. That is a standard ASCII. Whenever they say ASCII, go for standard ASCII. Extended ASCII uses 8-bit without the parity bit. So 7-bit plus 1 bit for parity, which means altogether we have 8 bits. So each character is 8-bit long. 2048 character is always 2048 multiplied by 8. Okay, so that marks the end of the this first session, and we'll continue with the question number 11. Take care, boys.